that's fun. So we go to marshmallow. You can have a marshmallow. The thing, you can also freeze other things, right? So a lot of objects have a fair amount of water content in them, and water freezes at 0 degrees Celsius, which is much higher than negative 200 Celsius. And then what happens is they become very brittle. And you can break them. Now, you won't want to put that in your mouth, right? The reason that you can throw marshmallows in your mouth right away is that they have a very low specific heat capacity, and so it doesn't draw off enough heat, enough temperature from your mouth to basically freeze. But anything that has water in it, you can kind of do this to, which is pretty awesome. It's trying to float. You can hold this a second. But it's trying to float. Okay. So you can also do stuff. It turns out that oxygen freezes at a temperature that is higher. Doesn't freeze, it condenses at a temperature higher than nitrogen does. And so what's supposed to occur okay, you can't, maybe you see it in the front row. Here. There's little drips that come off, right? Now that's not liquid nitrogen, there's no holes in the can. So what happens is that the oxygen in the air and some other stuff condenses on the outside of the thing and then drops. Now, if I was really brave or had taken time to see how it would work, it turns out oxygen is highly flammable, like pure oxygen, and so we can try to light it on fire. The other thing that we could do, but it would combust, and I'm not going to do that. So you can see a lot more of it now. The can's getting quite cold. The other thing is that oxygen is also paramagnetic, so you can take magnets and actually affect the path of the drop as it comes down. It's kind of hard to see, but you can actually like push it or pull it in a certain direction. Okay, so we have our rows, and you just shatter it.
It's kind of sad.
Right? What's the other thing? Okay, so this is also kind of cool. So this is something that I thought was neat. I didn't expect. So if you take a napkin, right, you can dip it in here. There's not very much. And you can pull it out. And I was like, oh, this is going to be awesome. Right? Watch this. And it doesn't shatter. Why doesn't it just shatter? It actually, if you look at it, it actually looks, quote, wet. It definitely looks like there's liquid in there, right? But that's nitrogen. That's just liquid nitrogen. There's no water to actually freeze. The thing that most often in these objects that freezes is the water content. And so what you have to do is get it wet with water, then freeze it. Then it'll break like crazy. But it doesn't actually do it. It just gets wet, which I think is pretty awesome. What was the other? Oh, so the other really neat thing that you can do is use liquid nitrogen for essentially clean surfaces. So I'm not sure if any of you have ever taken like a really, really hot pan and dumped water into it, like just tap water. You know what happens? It kind of, but if you put enough in, it does something really cool. Hope this shows up. Can you see that? It's like flying around the pan, like as if it has almost no viscosity whatsoever. And so you can observe this, you know, in any home or kitchen. You need a really hot pan, like get it really, really scorching, and then you do that. The water just like zips around like crazy. The cool thing is that the exact same thing occurs. Granted, this is not a hot pan, right? It is just at room temperature. Okay, this doesn't work quite as well. You might want to watch your feet. It's better if you do this in like a really big classroom or something that has a floor that's cool, like a non-carpeted floor. But you can do the exact same thing because the water is essentially evaporating. It's kind of riding on its own little cloud of non-liquid hydrogen, right? As it evaporates, it goes very quickly. It just kind of shoots across the thing. Everybody see that kind of. So the exact same thing happens as this. I don't know why this guy did this video for 4 minutes, but it keeps going.
It's so cool.
Science!
Yeah, the other
He says
strange
this, I've
thing
been
that you
recording
can do
for almost
that
6
seems
minutes.
a bit surprising is, despite the fact that it's really cold, because of this fact that it kind of falls off really quickly, you can do this. And it goes right off your hand. It doesn't. Now you don't stick your hand into it. That would be bad. You can actually. It turns out you can do it really, really fast, but like in and out. But I don't want to do that. But you can certainly pour it off your hand.
Actually,
It's the same thing.
your hand is wet.
Yeah, don't let it pool in your hand.
You
That'd be
stick
a
your
bad
hand
idea.
into
But the same thing will happen, right? It
and the
basically
same thing
evaporates the
You
instant it
can
touches your hand.
Yeah, really.
It's really cool.
As long as the letter. You put it in.
So yeah, that's kind of cool.
Look at the condensation.
Yeah, yeah.
That's how you know it's legit.
So if you want, you can come up and have a marshmallow